I want to say a few words about an interview here. It's a reaction to an interview on Latent Space. Shout out to Latent Space. They brought in two people from Base 10, that's an inference company, and they spoke about inference engineering. And before I even go to the details, which are important for us here at Launch Capital Partners, in particular because we have a large investment in Nvidia, I want to say that actually even the word inference engineering, in my opinion, is relatively new. Maybe not in the scene itself, but definitely for us investors, this is a new thing. And I think this is one of those that will stick. It's not like prompt engineering or whatever, Excel engineering or those stupid things. I think the problem of inference is actually, at least for now, a really difficult engineering problem. And what does it actually mean to be an engineering problem? In order to be an engineering problem, first, it has to be technical and it has to be solvable. So it's not a science problem. Like, you don't need to reinvent math here to solve the problems. And you also don't need to develop new materials and new physics. So you can solve it with continuous improvements, iteration, and technical solution. What would I mean with technical solutions? For example, you can have a scheduler that automatically assigns KV cache to compute based on the prompt, for example, or that even stores KV cache anticipating what the next prompts could be or what the next flow could be in an agentic world. So automatic optimization for inference, this is an engineering problem. And when people say things are an engineering problem, investors should be listening, because that is when we, as capital allocators, actually have a chance to participate in wealth creation. Because when engineering problems get solved, that's when wealth is created, assuming they of course they're solved in a way that there's a market and people see value. But if you don't solve the engineering problem, usually wealth cannot be created. So it's the first prerequisite for solving a problem. And I think now the way we see this long term, this will go away like many other problems or engineering disciplines within AI. It will be automated away, it will be abstracted away, but not in the near future. So I think, and this is not a call on Base 10 or Fireworks or others in the space. I think they're doing great work. I just think it's just how technology works. There was a time maybe when database management was a field, and I think at some point it just got automated, and the few actual necessary interventions that humans still have to make are at the high end, the white glove treatment of customers and things like that. But basically, fundamentally, all these things get done automatically. So the same way it's going to happen with inference engineering. But for now, it's an interesting space. And what I find most important about this interview is also, I think it gives you a glimpse into the future of the chip wars and what it means for companies like Nvidia. And we're large investors in Nvidia, so this makes a lot of sense. It's not even on podcast. Where it's August 10, 2026. This is Krim Delco for the year. We're down 17.8%. The market is up 11.3%, but we're falling by 29.1%, which is mainly driven by our Tesla. On the performance, we're not going to talk about Tesla right now directly. Let's talk about Nvidia. Let's talk about inference engineering. So what's the bottom line here? The bottom line is that inference engineering is a systems problem. It's not about programming an efficient kernel. It's not about putting tons of memory onto a chip and then have it run. That's not how it's going to work, because the workloads are changing. The workloads are flexible, automatic. They're general. We don't know what the future workloads will look like. Right now, they're incredibly agentic and code-driven. There could be video generation, for example, in the future. There could be a lot of design work. There could be workflows like in companies. So we don't know exactly how they will look like. But here's what we know. And I think it's good to lean back in situations like this and kind of try to predict what's not going to change. So what's not going to change is that people will automate a lot of the workflows that they can in order to save costs. People will always go for cheaper, better, and more value. And therefore, there is ample evidence that the demand for inference will increase. Now, what does inference actually mean? Inference is another word for taking value out of AI, right? That's what AI actually is a solution to a problem, and inference is the conduit for that. So you need the inference to get to the solution, whether it's manage your workflow. So, for example, I want to I want to form an LLC here in California. An agent does that for me, does all the paperwork, gets all the stamps, whatever it's necessary. This is a workflow, and the inference is the actual execution of that workflow. So it's a systems problem, and that's important because it means that the solution to inference is going to be at a system level. And that positions NVIDIA really well. I think NVIDIA has done a great work in the last 6 months to communicate this, whether it's Jensen, whether it's people. I just attended Future Memory Storage here in Santa Clara, conference about memory and storage. And the message there by NVIDIA and the industry is the same. The problem of memory, which is the bottleneck, in particular KV cache, which needs to be stored on memory, whether it's high bandwidth memory or other types of memory, that is right now the bottleneck, and it can be solved with systems thinking. So, for example, you can have an automatic allocation of KV cache to memory based on what kind of workflows you're anticipating in the next, in the near future. You need to coordinate the KV cache, which is part of the Vera Rubin platform solution that NVIDIA is offering as the next generation of their chips. I think we should get away from the nomenclature of chips and GPU and talk about inference systems, or maybe somebody else can come up with a better word, but a system for inference or a solution to AI, or even just workflow management or something like that, because it's really not about the chips anymore. It's not about efficient kernel programming. It's not about even CUDA, or it's the whole thing. But most importantly, you need to have a systems level approach and extreme co-design, which is what NVIDIA has been doing actually for years now. And I think it's actually becoming more and more important. So it's compounding. So this ability to co-design, which started with maybe Ampere or Hopper, is now even more important because inference is becoming a systems problem. Like I said in the prelude, I believe that fundamentally, at some point, we won't have inference engineering anymore because it will all happen under the hood. But as we speak right now, inference engineering is still a big problem, and I think the people from Base 10 are doing a great job in communicating that. Again, allocating KV cache, solving maybe memory allocation through network solutions. So instead of having lots of memory all over the cluster, you have maybe cheaper, a bit less hot memory, but extreme fast networking, which then can allocate memory as it's needed, weights as it's needed to maybe a more hotter memory, which is one of the solutions that were suggested. So more like hotter, more networking solutions. And I think Vera Rubin, the platform, the Vera is the CPU and Rubin is the GPU, is part of the solution. I think NVIDIA has good potential to continue grabbing large market share and grow with the market. Now there is room for others, and maybe I want to discuss a little bit. And this was also discussed in the podcast. There was a little bit of a conversation about ASICs, application-specific integrated circuits. So basically, dedicated models. They make sense in a world where you have one model provider, let's say OpenAI or Grok, and then you have a full stack, fully integrated based on that model, delivering solutions. I think that's what OpenAI is trying to build. That's what Musk is trying to build with SpaceX. And there could be a case maybe for SpaceX in particular, because what SpaceX is going to be after they merge with Tesla, it's going to be mainly a robotics company. That's what Tesla is. Tesla is an AI company, but it's a robotics AI company. And SpaceX has a model, which is Grok, but the penetration will be through embodied AI. And there is a case to be made that maybe like kind of in an Apple type of way, you will have a dedicated operating system for robotics, which starts with the Optimus and the Cybercabs and goes all the way down to the chip level, the AI 5 and 6 and 7, and even the energy in space and so forth. There is a case to be made for fully integrated AI companies, but there's also a case to be made for a fully flexible AI company, a company that is like, for example, Nvidia is serving lots of open models. And I think that's one of the trends that's very interesting, which is that you have, with open weight models, you have a problem, which is that they have different architectures, that they require more flexibility. And I think that's also part of the reason why Jensen is pushing for open models. It's not just that he doesn't want to depend on OpenAI or Anthropic, but he also actually, the open models require more flexibility, which is, of course, also, again, increasing the demand for system thinking. And that is the solution that Nvidia has to offer. So to summarize, inference is becoming more and more a systems problem. Nvidia is solving this inference problem by offering a flexible platform where a programmable ASIC, so it's still programmable, it's still general, but it's becoming more ASIC style because it is, Vera Rubin is an AI inference platform. So in that sense, it's not a graphics processor anymore or something like that, or a hypercomputer for physics simulation. I think before I go, I just want to say, I just want to make one note, and we've been talking about this a lot at the Not Even Wrong podcast. The demand for intelligence is going to grow exponentially. We're very confident about that. Whether it's going to happen in the next quarter or in the next 5 years, that I can't say, because there's a cost component here. There's also a budget component, there's a macro component. We can have a war and all that kind of stuff. But the fundamental idea that we have solutions to problems, technical problems, design problems, artistic problems, all kinds of problems. Not all the problems in the world can be solved with AI, but a lot of them can. And the more we solve, the better we can then come up with new ideas. So in other words, intelligence begets its own demand. So therefore, we think that the cycle will continue to grow. There is a new architecture being sort of in nascent, in green shoots, and that is continuous learning. I think that's an interesting field to look at. It's going to be a systems problem anyway. So I think as Nvidia investors, we should be okay on that front, but it's just something worth mentioning. And also this was mentioned in the podcast, that continuous learning, that is learning from inference and continuously updating your knowledge, whether it's updating weights or having a cluster of weights and then maybe statistically decide which one is more important. I don't know exactly, but you have this concept of continuous learning, which I think is what Richard Sutton was talking about last year in the Era of Experience blog post. That is the future of AI, and it was also discussed in this podcast. So again, I think this is a pivotal podcast, an important podcast, because it kind of sets the path for the future. Thank you.